our topic is first we will find minimum element in a given array, right? Finding minimum element in a given one-dimensional array. Okay, so this is a one-dimensional array I have assumed over here, array A having elements 0 indexes positions, right? So how many elements are there? 8 elements are there. So 7, 3, 14, 11, 5, minus 2, 4 and 1, right? I have written again these all elements over here without their this tabular representation. So what will be logic for the same? Anybody can tell me? Even I have written over here, but you can tell me how to find minimum among all the elements. This was among my notes also in PDF. Can anybody tell me any logic for the same?
सर किसी एक एलिमेंट को टारगेट ले लें, उसके बाद चेक करते जाएं.
Which element?
सर लाइक जैसे फर्स्ट एलिमेंट को टारगेट ले लें, उसके बाद उसको सेकंड एलिमेंट से थर्ड एलिमेंट से चेक करें.
Then
और जैसे सेकंड एलिमेंट
सर
अगर फर्स्ट वाले से
yes.
सर एक वेरिएबल मिनिमम में 9 स्टोर कर सकते हैं, फिर जो भी नंबर उससे छोटा होगा उसको मिनिमम में स्टोर कर सकते हैं.
Why 9 only?
सर सबसे बड़ा नंबर है ना
9.
सिंगल डिजिट्स में सबसे बड़ा है, तो हम लोग उससे कंपेयर कर सकते हैं.
But why you are taking only single digit? Any digit can be any number, right? Like I have written here 14 instead of this 144 can be written. Instead of storing maximum of one digit, you should go for maximum value of that integer variable. I'll tell you that logic later on, right? First go with this obvious logic, then I'll go for that one also. So first obvious logic is that Anmol has told just now that we can assume a number as minimum and compare all the other numbers, right? So if we are doing a sequential manner like linear search, right? Here we are finding means searching, right? Again, what searching or what we are searching for? We are searching for minimum element, right? So searching will go from either linearly or non-linearly, but here first we will go for linearly because linear representation is more easier or obvious also. So here if you are going linearly, then you can assume that your first element is minimum, right? You can assume that your first element is minimum, or you can say element at the first place is minimum. This is more absolute thing, that is element at first place is minimum. So now you have to compare this element at first place with element at second place. If element at second place is smaller than the previous assumed one, then this element at second place will become new minimum, right? Then this new minimum will be compared with third element. If third element is smaller than this new minimum, then third element will become minimum or new minimum. If third element is not smaller than second, like this 14 is not smaller like 3, then 3 will remain minimum. Then we will move ahead with fourth element, and now we will compare 3 with fourth element, right? If fourth element is smaller, then it will become minimum, but here it is 11, so there is no change and minimum will remain as it is 3, right? Then we will go for fifth element. We'll compare 3 with fifth element, because of this 14 and 11 our minimum has not been changed, right? So minimum is 3 at place index value 1, right, is minimum. So 5 is compared with that 3. Again 5 is not smaller, so 3 will remain as minimum. Next we will compare with minus 2. Now minus 2 is smaller than 3, so now your latest minimum will be minus 2. At which place it is? At place index value 5. So now next element will be compared with this latest minimum. So you have to compare 4 with minus 2 and 1 with minus 2, and we know that 4 and 1 both are larger than minus 2. So minus 2 will remain minimum among all the elements. after comparing with all the elements, right? So this is the way how we go. Anybody has any doubt? This is like, suppose we have 5 students in our class. 5 boys are there. Let me go with boys, right? So 5 boys are there. They are sitting in the front bench, right? Somebody is standing at podium, and somebody wants to find who is the smallest boy among all of them. Generally, we find the tallest one, but here I am trying to find the smallest, right? I am sitting at the podium. I am standing at the podium, and I'll call first boy, sitting at first place, right? Suppose bench is there, and first bench is like an array. So left to right, all the boys are sitting. I'll call first boy, right? And I'll assume that first boy is the minimum height boy, right? I'll keep that, say that boy to stand with me, right? Then I'll call second boy. If the boy I have called as first boy is less in height than the second boy, then second boy will go home and first boy will remain with me at podium, right? Or if the second boy is smaller in height than the first boy, then first boy will go home and second boy will remain at podium with me. Then we will call third boy. So third boy will be compared with the current minimum height boy standing with me at podium, right? Accordingly, if third boy is having less height, then third boy will remain with me, and the previous one that was first or second will go home. Or if third boy is having height higher than the current standing already with me at podium, then third boy will go home. Similarly, we'll do for fourth and fifth, and ultimately the boy standing with me will be the having the least height, right? Anybody has any doubt regarding this real world analogy? So the same applied over here also. Elements are kept in an array, and we are moving from left to right, and we have assumed that the leftmost element, that means the element at first index, 0 value index, first place, is the smallest one. Then that will be compared with the second element. If second element is element at second position or index value 1 is smaller, then our minimum element will become second one, right? If second element is larger, then we'll be with the previous one. Anybody has any doubt in this mathematical explanation? Please tell me now. So here, okay. So here I have written the same thing, right? Assume here first element is minimum. That means minimum is a pos min, where pos min is position. POS means position of minimum, right? I have assumed only POS underscore minimum. And the purpose of creating such kind of logic and teaching you such example is to implement selection sort later on. So understand this well, then definitely you will get a selection sort in one go, right? So suppose I have assumed first element is minimum. So first element is minimum. So what is the index position of first element? Position of minimum is 0. Okay. And the element will be, because the name of array is A, so this will be the element A pos minimum, right? Okay. Anybody has any doubt? Please ask. I can write this also. Minimum is at pos minimum 0. So element is this. Element is this, right? This first element is compared with second element of array. So second element means what will be pos minimum for that? 1, right? Okay. So second element compare kar rahe hain, that means what I am trying to say? I am trying to say here, if A1 is less than A pos minimum, position of minimum, that is I want to say, right? If my second element, that is A1, is less than my assumed minimum element, and assumed minimum element is at position index 0, that is a pos minimum, right? If it is okay, this condition, have you got it correctly?
Yes, sir.
Okay, so if it is true, then what will happen? Then my this 1 will become new value of pos minimum. If it is true, right? If first element is smaller, then it will remain minimum. Otherwise, second element will become minimum, and second element will become minimum. That means now my pos underscore min will become 1. Earlier, I have assumed pos underscore min as 0, but this condition is true here. Your second element, that is element at 1th place, 1th index, second element is less. This is true. So this will be new value of minimum index, right? Similarly, now we will compare. Now our what will be my new condition for third one? I'll write it again over here. So in place of 1, I'll write here 2, right? Second element, right? We'll compare with third element. Like this, it will become A2 will be compared, then A3 will be compared, A4 will be compared. So how many elements I have? I will compare. So that means I will compare AI. That means in general. So in general, I'll compare. What I'll compare here? I'll compare AI. AI with a pause. I can write in general. Right? That means I'll write a for loop, and this will be the condition within for loop. And if this is true, then what I will write? I'll write pos underscore min is equal to I. Whichever I is smaller, then that I will become position of minimum element. Is this okay? This condition?
Yes, sir.
Okay. Anybody is not comfortable, please tell me immediately with these terminologies, with these assumptions. Whatever you have learned earlier, maybe you have assumed a min, a variable, and min is equal to A0 and going with that, right? But I have changed a little bit. I am working with position only, index value only. If you have index value, then definitely you can print that element immediately. Just passing it inside A, you will get that minimum value. So why should we take another variable to store a minimum value? Okay, if logic is clear, we should go to program. Okay, right. So now I'll go to program. I'll share screen with you. And that program again I have made using functions, right? I have already created that program in previous class. If you'll say me to create it again, I'll create it again, but I don't think it is so difficult that you cannot understand by this directly. So here my name of function is find minimum, right? What I have passed array and size of array. See this function first, don't see main, even it is written over here. Don't see this first, see this function first. Right? So find minimum is the name of my function that will print minimum element in a given array, right? This is my array and this is program. Okay, so here I have written int I, position of minimum is equal to 0, as I have done here also. Position of minimum is equal to 0, that thing I have written already here, right? So here I have initialized position of minimum element as 0 because I have assumed the first element is minimum. So now I am running a for loop and I am running from I is equal to 1 because I want to compare this with second element, and second element is at index 1. So I am starting this for loop for I is equal to 1, not with I is equal to 0, because 0th element is already assumed to be minimum. So अपने आप से क्यों compare करें? So I have assumed it with I have started comparison with the second element. So second element A0 is compared with A1 is compared with a pos min. What was value of pos min? 0. So I am doing with this iteration, A1 less than or this. If second element is smaller, here it is smaller, 3 is smaller. So what will be new value of minimum elements index? Index of that I, right? That will be 1, right? Then this for loop will move ahead. I will become 2 now. So now you will compare A2 with new value of pos minimum, that was 1, right? That was element 3, value was 1 earlier. So now A3 is actually calculated with, A2 is calculated with A1 compared, right? So here value 14 is compared with 3, right? Okay. So this is not minimum. So condition is not true. Nothing will be changed. Then I will move ahead. Still your pos minimum is index value 1. The value of index at 3 value, right? So now you will move ahead with value I as 3. So I3 is 11. So now you are comparing A3 with A1. A3 with A1, yani 11 with 3. Again, condition will not change. Condition will not true. So no pos minimum will be changed. I will be incremented to 4. Value is 5 now. So now you are comparing A4 with A1. Every time A1, right? Because you have not changed till now. Again, 5 is larger than 3. Nothing will be changed. Condition is not true. Pos minimum equal to I will not run, right? So pos minimum will remain as it is 1. Now I will increment to 5. So now you are comparing A5 with A1, right? A5 is compared with A1. That is -2 is compared with 3. Now this condition is true. When A5 is less than A1, I have written. This condition is true. Yes, A5 is less, -2 is less. So now your I will become 5. I is 5. So pos min will become 5. Earlier it was 1. Now it will become 5. Right? I will increment to 6. Now you will compare A6 with A5. Right? Last value of pos minimum was 5. No change. Then A7, again no change. So pos minimum you have obtained here as value of I5. Right? So that loop is terminated because I less than S is the condition size, right? And then you will print result. %d is minimum element at place %d. So what pos minimum you have obtained, you will pass here. So this will print value of minimum element. And if you want which element it is, first, second, third, fourth, so +1 will be done because pos minimum is actually accepting values of I index, and index starts from 0, right? So this -2 is actually which element? This is actually 6th element. First, second, third, fourth, fifth, 6th element. But its index value is 5. So actually pos underscore min has 5, right? And this is 6th element. So we have to write +1. Is that clear to all of you? Anybody has any doubt regarding this program? This function will work and printf result will be shown within this function only. In main, I have assumed this initialize with this array. One more thing I have written over here, z, and z is actually number of elements. So here I am calculating what? Number of elements in array. How it is calculated? Size of entire array, number of bytes, and divide by size of one element. Size of entire array will be 1, 2, 3, 4, 5, 6, 7, 8 elements are there. So 8 4s are 32 or 8 2s are 16. Whatever is my processor, irrelevant. Size of integer will be accordingly. So 32 divided by 4 is 8. Let's see output for the same. If there is any doubt, you can ask me now. You should take screenshot of the program so that you can use it later on. or write it down anywhere. If you know, you can write, or you can remember also. I have executed it and it will show me -2 at which place? 6th place. 1, 2, 3, 4, 5. 6th place element -2. This printf will run and it will give me output for the same. Right? So I have got output. This is the output. -2 is minimum value at place 6. Okay. Anybody has any doubt? If suppose I want to find maximum, then only this change is required. Less than is changed by greater than. Name of variables will be changed, but result will be found by this. So if I'll execute it, so which value I'll found, what will be my result? 14. So 14 is the maximum element at 3rd place. So now result will show, because minimum is written everywhere, so it will show minimum, result will show minimum, but actually I have changed the logic and it will show me maximum result, right? Element maximum value. Every time you are comparing with your, so 14 is maximum element actually, because I have changed logic over here, and at place 3. Any doubts, anybody? So this was for minimum, finding minimum. Now that thing Anisha was telling that you can give a value, smaller value, larger value kind of thing, right? That is not required over here, because I am going with the position of minimum. I am not going with the value. Right? I'll tell you that logic later on, but let me start with current topic, that is selection sort. So what is selection sort actually? Selection sort is finding minimum and placing it properly, right? So first I'll tell you numerical example, then all the theory about it. So instead of finding minimum, I am doing selection sort, right? For this given array elements. In place of this, I am writing selection sort. So what is the definition of what is this sort? Sort is actually placing elements in ascending order or descending order, right? Because this is essential. In some applications, it is essential. Even if in your dictionary, in your phone book, everything is sorted and alphabetically sorted they are. And number wise also there is a requirement of sorting. So we are doing sorting, right? So here, first technique that we are going to discuss in sorting is selection sort. So how it can be done, we'll learn it soon. So selection sort in 1D array is actually, we can write here one statement, find for this, finding minimum at a time and finding minimum at a time and fixing it at its proper place to create ascending order list of elements, right? Or ascending order array, anything. Array is also list of elements. So finding minimum element at a time and fixing it at its proper place. Are you getting this definition correctly? So every time we have to find minimum and we will fix its place and move ahead, right? So now we'll start with this, keep this as it is. Now I'm telling you numerical example for this selection sort, then I'll go for program and theoretically other things related to this. I have again written all the elements in this manner: 7, 3, 14, 11, -5, 22, 4 and 1. So these are the given elements to me, right? So what is sorting in this way? Suppose you are going to sort this array having 2 elements. Suppose first element is 5, 4 and second element is 5. So this is already sorted. because left element is smaller, right element is larger in ascending order, obviously. If your elements are like 7, 3 or 2, then this is out of order because your left element is larger. So you have to perform swapping, right? After swapping, you will get 2, 7. Now it is again ascending order. So this is sorted. So any two elements can be swapped, can interchanged, and then we will get sorted array, right? If they are out of order only. So here also we have to perform swapping. So comparison and swapping is generally the key operation in all type of sorting, right? In generally, I am saying generally, not every time. So now I'll start with the first element 7, right? I'll assume this is the minimum element and will compare it with remaining all the elements. Actually, I am trying to find minimum among all these. If you know procedure how to find minimum, then definitely you will get -5 as the result, right? And -5 will be swapped with the first element. This is the first basic thing, right? So now your array will become 7, suppose I have written again the same array. I have written the same array. So now you are picking this. So I have made it red, right? 7. And you have found smallest element. So you have smallest element is this -5, right? Suppose I have written it green. Now this red and green will be swapped. So now this will be -5, and in place of -5 you will have 7. That means -5 has got its correct place because -5 is the smallest in entire list, so it should be at the first place in ascending order, right? So now this has got its place, right? -5 has got its place. So I'll made it in a different color, suppose purple. Let me increase font size more. So now -5 is sorted. So what are the elements unsorted? The remaining elements are unsorted. So we will apply the same minimum finding and swapping with the first element in remaining elements. So now which one is the first element in remaining elements? 3, right? We'll pick that 3 and find minimum with our previous approach, finding minimum. So which one is the minimum? 1 is the minimum, right? 1 is the minimum. I'll take 1. So now I'll swap this red with the green. Okay. I'll write again everything, and green and red are swapped. So here it will be 1 and here it will be 3, right? So now 1 has got its place correctly. 1 has got its place correctly. So unsorted area is now this. Again, within this, first one will be picked. So first one will be, because we want to find minimum among remaining elements, unsorted elements, right? Minimum. So first element we will pick and compare with the second, third, fourth, fifth, and in the same way as you have found minimum, we will find minimum like this. So 3 will be the minimum now by applying that procedure of finding minimum. So now 3 must be at first place in this unsorted array, right? In this unsorted array, 3 must be at first place, and first place is occupied by 14. So we will swap them both, right? So 3 will be swapped with 14. So here it will be 3 and here it will be 14. Now 3 has got its place correctly, right? 3 has got its place correctly. So now remaining elements are unsorted are these elements again. So we will pick here 11. We'll pick here 11. Oh, sorry. So this is obtained over here. So I'll copy this again. One step I have missed over here. So it is like this. Let me go previously. An explanation is correctly done, but actually I have to copy this one, right? Like this. So now okay, this 14 7, then minus 5 3, then 14. Now it is okay. Now it is okay, right? So now this will be 3 and here it will be 14 and 3 is actually sorted, right? Now 11 will be picked next time. So 11 will become red now and I have to do this over here, right? Now we'll find minimum among these elements, all the elements. So minimum is now 4, right? So 4 will become green. 4 will become green, and now 4 and 11 will be swapped. So here it will be 4, and here it will be 11, right? So now 4 has got its place correctly. Okay. So next element will be 7 that we will pick. That element will be 7 now. Come again. If anything is wrong, please tell me immediately, right? 7 I have taken over here. So now with these elements, I have to find minimum. So that 7 is the minimum. So we will not swap anywhere with the 7. So 7 will get its place and its color will be changed only. We will compare 7 with all of them. Nobody will replace 7 because 7 is already minimum. So next element will become 22, right? So now 22 will be picked up. So 22 is picked up now, and then I'm again writing them. So 22. Now 22, this list is actually considered with 22 as first element, and we are finding minimum. So find minimum is 11. So 11 will swap this, right? And here it will be 22. So 11 will get its place correctly. 11 will get its place correctly. Then we will have 22. Next element will become 22, right? So now your list is having only 2 elements. List is having only 2 elements, and within them 22 is the first one. So 22 is compared with 14. 14 is the smaller one, right? 14 is the smaller one over here. So it will be swapped with 14. So 14 will come here and 22 will become here, and 14 will get its proper place. So color will be changed accordingly, right? So now remaining unsorted elements are only 1. Whenever there is only 1 element, then it is already sorted. If you are running in a race, you are a single person, then definitely you will be winner. Similarly, if we have 2 elements, then only we can compare ascending or descending. If there is only 1 element, then there is no need of comparison. That means it is already sorted. So that means now 22 will be considered, but it is already sorted. So our sorting is completed and we have got all the elements sorted. So what was the procedure? Finding minimum every time. So here every time it will be -5. Copy paste is not done properly. Is that clear to all of you? Mathematical example?
Yes, sir.
Anybody has any doubt, please tell me immediately. Every time you are taking first element and finding minimum in entire unsorted array. Here I can show you one more thing. I can show here one more imaginary boundary. Suppose you are having these things. So suppose this entire array is given to you. So this entire array is unsorted. Okay. So entire array is unsorted. So this boundary has all the elements unsorted from this to this place, and there is no element in sorted portion, right? Then first time you have executed, so this is actually all the elements unsorted over here. Then you have found first element, you have found first minimum element. So now your remaining elements are these one, this is unsorted, and this part is sorted. -5, single element in sorted. Then next time this list of elements are unsorted and sorted elements are 2 elements. So every time one minimum, more minimum will be found, and sorted elements will increase, keep on increasing. So now next time these 3 elements are sorted and unsorted part is like this. Similarly, these are sorted and remaining elements are unsorted. So every time in remaining elements, we will apply that finding minimum approach. Sorry. Right? Remaining elements. When one element is remaining, already sorted. So these are the things. How your imaginary wall is moving from left to right. Right? And all the elements are getting sorted slowly. And this entire list is now sorted. Even if one element is repeated or written twice, one more time, then also same thing will be applied, and those both similar elements will remain side by side. Is this clear to all of you?
Yes, sir.
Anybody has any doubt? Please tell me. Ayan, have you got it? Ayan Shukla? Okay. Good. So here, how many for loops are required? Kashish, want to say anything?
No, sir.
Okay. So here in this case, how many for loops are required? One for loop is required for finding minimum, right? And another for loop is required for every time we are picking next first element of next unsorted array. Are you getting this point? So initially, first element 7 was picked, and that was compared with all of them, and finding minimum was applied. Okay. Then next time, when loop will iterate, so next time this finding minimum will be applied on this, right? So your first element will be changed. So now first element will become 3. Next time you have to apply with this. So first element has been changed, first element will be 14. So one loop will change first element every time, and another loop will find minimum among that array, right? So there are 2 for loops required for this purpose. Are you getting this point? In finding minimum, only one for loop was required, as I have told you here. You can see this one. Only one for loop was required in finding minimum, right? But here you are not finding minimum. You are finding minimum and placing it at the proper place also, right? By swapping, right? Then next finding minimum process, you have next first element. So next first element will be created in the same manner, right? So let me take you to the code now, so that it should be completed. Is this visible to all of you? Dave, see screen. Is this visible?
Yes, sir.
Okay.
Yes, sir.
Okay. So here you can see how logic is applied, or okay, let me go to the slides and show you how it works. Okay, this is the selection sort program. Take snapshot or a screenshot of the same. So first function I have written here is a swap function, right? Swap function, as I have done swapping in my mathematical representation. When first we have assumed first element is minimum, then we have found minimum element among given elements. If new minimum is found, then first element is swapped that new minimum with that new minimum, right? So that thing is applied over here using this logic of swapping. Which logic is applied over here? Call by reference technique, right? Call by reference technique. Wherever swapping will be required, I will call that thing. Okay. So this is selection sort. I, min. I have assumed here that was pose min. Instead of pose min, I have assumed here only min. So I is equal to 0 for loop. So outer for loop is running from 0 to last but 1, because you have picked that thing, right? In my example, you have seen over here, I have picked 7, then 3, then 14, then 11, right? Then 7, 22. Finally, when we have only one element in the last, then that will not be picked, right? When there was only a single element, then it is already sorted. So this outer loop is running how many times? N minus 1 times, not n times. So it is running from 0 to n minus 2. That is n minus 1 times, right? Are you getting this point? Then I'll assume minimum position index is I. So 0, that means first element, right? First element. Okay. So see this logic over here. So inner for loop will run j is equal to I plus 1. So when I is 0, first element is taken, then second element will be A1 to last, right? So I is 0, so j will run from 1 to last. When I will be 1, I have picked this second element and finding minimum among these list, right? First element I have got, minus 5 is fixed. Now remaining elements are from 3 to 1. So I have picked 3, right? I want to find the minimum in this array. So this 3 is actually at which index? At index number 1. So now I will be 1, right? 3 is assumed 1. So I will compare with the 14, and 14 is I plus 1, that is 2. So j is actually 2 to n, 2 to n minus 1, right? And every time if aj is less than a min, then min is equal to j, right? This is finding minimum logic. And when this loop will run completely, then at particular array I have found minimum, then I'll swap. Are you getting this logic correctly? Anybody has any doubt with this one? Please tell me immediately. If you are correctly getting it, then take a screenshot for the same also. Selection shot. What I have told you, look, in finding minimum, I was finding only minimum position element and printing that value. But here, if in this case, if I have found a minimum element, then I will swap this minimum element with the first element. So first element is whatever value of I you have taken is the first element that you are comparing with all the elements. So j is running from 2 to last. If you have found a minimum, new minimum, that was 1 over here. So that one element now 1 will be swapped with 3. So now this 1 is actually new minimum, right? Because you have found it minimum, and that is swapped with your assumed minimum. Assumed minimum was a0. So this swapping logic is applied over here. This is addresses, because I am using which function? Call by reference. So I have used here addresses in swapping. If you have any doubt, you can ask me again, or should I go with this in next lecture also? Anybody, please tell me. Have you got this one? Correct?
Yes, sir.